All right, hey guys, we're back again. Chapter 2, Section 2, Day 2. All right, we're going to be working on writing equations of tangent lines. So today we really got 7 examples, so we're going to dive right on in. So the first couple examples, they're asking us to find the equation of the tangent line to the graph of f at the indicated point. So for one, we got a function of x. We got x cubed plus 2x squared minus 1, and we want to find the tangent line at 1, 2. Okay, so our steps that we're going to go through here are we're going to find the slope first, right? We got to find the slope first by taking the derivative of our function. Once we have that, we have the point, we have a slope, so we're going to go through, put it in our y equals mx plus b. Okay, so let's get started. For one, we're going to take the derivative. Let me get my marker up and ready. Okay, so we're going to go f prime of x. It's going to be 3x squared plus 4x. All right. And now if we want to find out what the slope is at a certain point, we're going to take the x component right there, 1. We're going to plug it in. So we're going to have f prime of x, or not of x, excuse me, of 1 equals 3, 1 squared plus 4, 1 times 1. Okay, what you get when you solve this all out should get a nice 7. Okay, so we know our slope at that point is 7. So I'll write up here, our m equals 7. So now we're going to plug it into our slope-intercept form. All right, and now we'll simplify it there so we get it into something neat. Left with y minus 2. 7x minus 7, so then y equals 7x minus 5. All right, found our slope, and we found the tangent line for that point. Okay, not too hard. Take the derivative, find your slope at the point with your x component right here, plug it all in, and get your line. So let's go on to 2. All right, we're going to take the derivative here. Remember, 1 over the cubed root, or that's the same thing as 1 over x to the 1/3, which is the same as x to the negative 1/3. Okay? So when we take the derivative, we're going to get a nice negative 1/3 x minus 4/3 up here. Okay, we can make that look a little nicer. And get negative 1 over 3x to the 4/3. And then now we're going to take our point. We got 8 for our x. We're going to plug that in. So f prime of 8 equals negative 1 over 3 times the cube root of 8 to the 4th. Okay, when you plug that all into your calculator, you should get a negative 1 over 3.16. I'm sorry, 3, that's not, jeez. 3 times 16. And so what you're going to get in the end is going to be negative 1 over 48 equals your m. All right, now we got our slope. Now we're going to take it over to our point. All right, our m equals negative 1 over 48. We're going to plug it all in. Y minus 1/2 equals negative 1 over 48 times x minus your 8. I'm going to simplify this. All right, and we end up with our y equals negative 1 over 48 x plus 2/3. Okay? So again, what we're doing, taking the derivative to find the slope, plugging in our x component from our point, and then we're taking it all back into our y equals mx plus b form. Nothing too difficult. All right, we're moving on to 3. Let's change up these colors. All right, moving on to 3. We have some here. We're going to expand it out to start. Right? 2x3 minus x squared plus 6x minus 3. Okay, same thing as that. So now when we take the derivative, f prime of x, going to get 6x squared minus 2x plus 6. And that's going to... Then we're going to take our 2, plug that in, give us 6 times 2 squared minus 4 plus 6. Okay, this is going to equal 26, which is our m. All right, our m equals 26. Start plugging it into our y equals mx plus b. Y minus 21 equals 26x minus 2. Alright, so we got y minus 21 equals 26x minus 52 plus 21. Brought that all over at the same time, and you're going to get your y equals 26x minus 31. And that's our answer. Let's move on over to 4. Okay, got something a little different. We got some sine mixed in there, but that's no problem because we remember all our properties, and we know that when we take the derivative of a constant, it goes away, and when we take the derivative of sine, it just goes to cosine of x. All right, so now we're going to plug it in, and we want to know what it is at x equals 0. Plug in 0 right there, you get cosine of x, or sorry, not of x, of 0. We know that equals 1. So our slope is 1. So now we have to find out what, we know our slope is 1, and we need an f of x value. All right, so what we're going to do here is we're going to plug it in just our regular function at 0, okay, because we got to get our f of x to 0, not our f prime. Remember, this is just f of 0. So we're going to do 1 plus sine of 0 right here. We know that that then equals 1, which is what our y is going to be. So it's going to equal our y component. So our point is actually going to be 0, 1. All right, so now we take our little formula, plug all our stuff in, like that, simplify. Get x equals, or y equals x plus 1. Okay, all I did there was, notice we only had an x component, so we had to go back to our original equation and plug in that x component to get our true point, which is just 0, 1. Okay, slope for our slope process is still the exact same. Okay, here we go. Now we're going to move on to something a little different, all right? New set of problems. We got 5. It says determine the points, if any, at which the function has a horizontal tangent. Okay, remember, horizontal tangent just means slope is 0. Okay, we're dealing with a slope of 0. So we're looking at y. We're going to have to do the same thing. Remember, another way to write that is just y prime as well. Okay, so that's what we're going to use for this one because they're putting it in terms of y. So the first thing we're going to do here is we're going to find y prime. all right, which is just taking the derivative of y. Then we're going to set it equal to 0 because we need to find out when the slope is at 0. And we're going to solve for that. And if it's possible, then we're going to go on from there to find the horizontal tangent. So, first step for 5, we're going to take the derivative. We got our y prime equals 2 plus cosine of x. Okay, so now if we set it equal to 0, okay, we start to simplify. We get negative 2 equals cosine of x. But wait, that's not possible. There's nothing you can plug in to get that. So this is one of those things, if any. So we'd say not possible. So it has no horizontal tangents. Okay, so that's one of those ones that there isn't any. So we can stop right there. Easy one. All right. Next one's not going to be so easy. We're going to have to keep doing our work. So 6. We're going to do the same process. We're going to start by taking our y prime. Okay, we're going to get y prime. We're going to get 9x squared minus 4x. Okay, now we're going to set it equal to 0, right? Our m must equal 0. So we're going to go 0 equals 9x squared minus 4x. All right, we factor that out. We get a 0 equals, factor the x out. Okay, and now we're just solving for 0. Just looking at this, we should be able to see that x equals 0 and x equals 4/9. So we have 2 different points. So now we're going to have to plug back into y. Okay, so we're going to go back up here, right? When our x equals 0, the first one we're going to do is x equals 0. So we're going to have our y equals 3, 0 to the third minus 2, 0 to the third. Notice we're back to y. This isn't y prime. We're plugging these points back in. It's kind of like what we did at that last one in 4. All right, you get y equals 0. So your point is going to be 0, 0. All right, just your answer there. So now for x equals 4/9, we have y equals 3 4/9 cubed minus 2 4/9 squared. Okay, we're gonna do a little simplification. You get 3 times, I think, 64 over 729 minus 2 over 1681. And we're going to simplify this to, it's going to be 64 over 243 minus 32 over 81, which equals negative 32 over oh wait, I messed up here. That's right, these numbers. Okay. So we're going to go 64 over 243 minus 96 over 243. So we have like terms. And that should give you 32 over 243. Okay. So our result is, all right, our x, what we plugged in was 4/9. What we got out, 32 over 243. All right. That's your answer. Sorry, and that's a negative. Jeez, I'm all over the place. I'm losing my negatives. Plus minus. Yes. All right. So that's good. Make sure you do better than me at keeping track of those negatives and all your fractions. All right, last one, 7. Not too bad. So again, we're going to take our y prime over here. We got cosine and sine. So our y prime is going to give us a negative sine of x plus a cosine of x. All right, when we set it equal to 0. All right, so we get sine of x equals cosine of x. So the points we're looking for, our x points, are when our two results equal the same thing. All right, so you should be able to flash back to some unit circle stuff. Think about when do we have the same things for our sine of x and cosine of x? Or you can think about it on the rectangular chart like this. Think about it like this. If you have your sine, oh, that's pretty bad. All right, we have, let's say, 2 pi. You got something like that, and then we got let's see if I can do this. Something like that. So really, you should have 2 points that they intersect at. See, the graphing doesn't help me as much. The way I think about it is on the unit circle. What are those 2 points where they have the same thing, right? The only time that happens is when we have square root of 2 over 2, right? And the only time we have those between, between pi and 2 pi is our pi over 4 and 5 pi over 4. Okay? So that's what our x equals. Pi over 4 and 5 pi over 4. Okay, that's when it's the two same, right? It's negative square root of 2 over 2 and it's positive square root of 2 over 2, and they're the same thing. So now we're going to keep continuing on with our process. Now we're going to plug in pi over 4 for our first one. So we have y of cosine of pi over 4 plus sine of pi over 4. Okay. It's going to get us, like I just said, square root of 2 over 2 plus square root of 2 over 2. That gives you 2 square root of 2 over 2, which gets you square root of 2. Okay, so this point is going to be square root of 4, or pi over 4 square root of 2. 1 point. The next one, we have y equals cosine of 5 pi over 4 plus sine of 5 pi over 4. Right? Oops. That's going to get us negative square root of 2 over 2. It's negative square root of 2 over 2. It's going to equal negative 2 square root of 2 over 2. It's going to equal a negative square root of 2. Okay, so for this one we have 5 pi over 4 negative square root of 2. Those are your two answers. And that's it. All right. Again, let me know if you guys need any help with your homework problems. Feel free to text or email me, whatever.